Hi, 8th grade. Welcome to your last lesson of Topic 4, Interpret Two-Way Relative Frequency Tables. By the end of this lesson, I want you to be able to say, I can find the relative frequencies of two-way tables and interpret what they mean. Let's solve and discuss it. Mr. Day's math class asked 200 cell phone owners which size phone they prefer. They presented the results in a two-way frequency table. How can you use the data to compare the percent of students who choose the small screen to the percent of the percent of adults who choose the small screen? So I want you to pause the video and write something down, jot something down on how we can do it, or maybe the numbers you come from, and we'll press play when you're ready. All right, so percent. Percent goes back to part over whole equals percent over 100. Remember that from last year. Percent of students who choose small screen. So there are 48 students who choose small screen out of a total of 100. So that's, I'm going to write students. So that's 48 out of 100 equals percent over 100. Well, we don't actually even have to do any cross multiplying or solving. The percent is 45. You can see we don't have to do anything to the 100. So the percent is 48% of students. Then we're going to do the same thing with adults. And it is 18 adults out of 100 total. So 18 over 100 equals our percent over 100. So it's 18%. So more students prefer the small screen than adults, which makes sense because adults sometimes have poor vision, so they would want a bigger screen. How does knowing a percentage change the way you interpret the results? Well, that is helpful. Helpful when you don't interview the same amount of people. So it's a better comparison. Okay, because this was easy to compare because, you interviewed 100 adults and 100 students. But if you were to interview like 50 students and 100 adults, the information would be a little bit skewed. So finding the percent will help us deal with that skewedness. Example 1. Construct a two-way relative frequency table. This lesson is going to be pretty simple because last lesson we talked about constructing a two-way frequency table. Now all they've added is the word relative. So that just means finding the percentages. Caden asked 150 parents and students, so that's where our 150 total comes from, about their preferred method of communication. What percent of people polled were students who preferred email? So the first step is to make the two-way frequency table, and we can make that from his information here. They did that for us. And the next thing is to make a two-way relative frequency table. Now here's one of your vocab words. A relative frequency table shows the ratio of the number of data in each category to the total number of data items. The ratio can be expressed as a fraction, decimal, or percent. So the parents who emailed was 18 out of this 150. So that's why they did 18 divided by 150. Then they need to multiply by 100. That will give you 12%. Again, 18 divided by 150 gives you 12%. Next thing you do would be 12 divided by 150. So you do 12 over 150. And then you multiply by 100 to give us this 8%. So it literally just goes in the same spot on the relative frequency table, but you have to do the part over the whole and then multiply by 100 to find the percent. Still works as before, where if you add up 12 plus 8, you will get 20. 12 plus 68 is 80. 24 plus 76 is 100. And you can add down as well. That will also be your check. So the question was, what percent of people polled were students who preferred email? So we look students and email, and we get 12%. 12% of the people polled were students who preferred email. Let's try it. Asia asked 82 classmates whether they play sports on the weekend. The results are shown in the two-way frequency table below. So you definitely need your calculator for this whole lesson. So we're going to use her two-way frequency table to complete the two-way relative frequency table. Remember that word relative means that we got to put in the percentages. They already put in this 100 here because we know that's the total out of the total. It should be 100%. So we're going to go through this first one. Boys who say yes is 21 divided by 82, and we have to multiply that by 100. So 21 divided by 82, and then multiply by 100, and you can round. So this gives us 25.6. So we're going to go ahead and round that up to 26%. Next one you do, 18 divided by 82 times 100. I'm not going to write it out for every one. And you get 21.95, so we're going to round that up to 22. And again, we can add those. 26 plus 22 gives me 48. Now, girls who play sports on the weekend, 26 out of 82. 26 divided by 82 times 100 gives me 31.7, so I'm going to do 32. And now I can add down. 26 plus 32 gives me 58. And last one I need to find is girls who say no. So that's 17 out of the total 82 times 100 gives me 20.7. So I'm going to round that up to 21. Add them down gives me 43. Add across gives me 32 plus 21, 53. Okay, now you might be saying, okay, Ms. Dressinger, you said you have to be able to check. 48 plus 53 actually gives us 101. And same thing here, 58 plus 43 gives us 101. That's just the issue of rounding. As long as you're very close to 100, you'll be okay. How is the two-way relative frequency table different from a two-way frequency table? Pause the video. I want to hear some answers for this. All right, hopefully you said that the relative frequency table has percentages. All right, example number 2. This is comparing relative frequency by rows. So we just compared the relative frequency out of the entire total. This is when we just look at the rows. So use the given data to make a two-way relative frequency table by rows. According to the row relative frequency table, and row is straight across left and right like horizontal, what percent of students polled attended the last home game compared to the percent of faculty polled who attended the last whole game? So they did the number of students, 42 out of the total students, 42 that said yes. So you do 42 divided by 68 and multiply by 100. Same thing then when they did the no, you do the no's, students who said no, out of the total students. You're just staying in the row, and that gave us 38.2%. Then they look at the faculty, 15 out of 27 by the row, so part over whole. The total is the row total, and that gave them 55.6%, and the same thing with the no's. 72 divided by 27 and multiplied by 100. Okay, then, so it's very important, you cannot add down. Since it's only by rows, you can only add across, and you should get 100. Add across, and you should get 100. So then when you're trying to find this percentage, the total of 57, you divide that by 95 to get 60. Same thing, 38 divided by 95 to get 40, and you add across because it's by rows. So the question was, what percent of students polled attended the last home game compared to the percent of faculty who attended the last whole game? So 61.8% of students polled attended the last home game, which is more than, so they want you to be able to interpret it. What do the numbers actually mean? So it's more than 55.6% of the faculty polled who attended the last home game. So this is very important. This is like final wrap up the rows. The data you need to compare are in two different rows. Divide each frequency by the row total, not the whole total table total. Example 3, compare relative frequency by columns. Okay, so row was left and right horizontal. Columns is up and down vertical. So you do the same thing, but now you're comparing vertically. 85 over 207. 125 over 197. And again, since we're doing it by columns, you can only add up and down, not side to side. Only add up and down. The data you need to compare are in two different columns. Divide each frequency by the column total, not the table total. So if you're doing it by columns, you do it by the column total. So the question was, according to the column relative frequency table, do 8th graders check out a greater percentage of ebooks than 7th graders? So we're looking at the ebooks, and we're looking at 7th versus 8th grade. So yes, of the 8th graders, 63.5% have checked out an ebook compared to 41.1% of the 7th graders. So since 63 is more than 41, greater than, it is true. Use the data in the table above, Part A. How does the percent of students who choose ebooks compare to the percent of students who choose audiobooks? So now we're looking at like total students, not versus 7th versus 8th grade. All students, the percentages. So pause the video, write something down, and we will look for participation. Hopefully you said that 52% prefer prefer ebooks, which is greater than 48% that prefer audio. They really want you to be able to interpret the graph or interpret the column and be able to say what they're asking for. Is there evidence that 7th graders have a greater tendency to choose audiobooks? Explain. Pause the video, participate. Okay, so is there evidence? So 7th graders have a greater tendency to choose audiobooks. So we're going to look at the 7th graders, and it says in the 7th grade column, 58.9% choose audio and 41.1% choose ebooks. So yes, because 58.9 prefer audio to 41.1% ebook. All right, key concept on the next page. Relative frequency is the ratio, so part over whole, of a data value to the total of a row, a column, or the entire data set. It is expressed as a percent. So relative frequency, oops, I didn't mean to block that out. Relative frequency, think percent. A total two-way relative frequency table gives the percent of the population that is in each group. In a row two-way relative frequency, the percents in each row add up to 100. In a column two-way frequency table, the percents in each column add up to 100. All right, 8th grade, let's say it. I can find the relative frequencies of two-way tables and interpret what they mean. Have a great day.